Integration by parts 2. Integral u dv is equal to uv minus integral v du. This is the reverse of product rule. The strategy is choose u easy to differentiate, choose dv easy to integrate. So we will let u be equal to ln x squared, and dv is equal to dx. Let's write that down. U is equal to ln x all squared du. Apply the power rule, 2 times ln x, differentiate the inside, that's the chain rule, times 1 over x dx. Dv is equal to dx. Integrate both sides, we get v is equal to x. Apply the formula, u times v, that's x times ln x all squared minus integral v du, that's x times this. So x times 2 ln x times 1 over x dx. Cancel out the x's, take out the 2, we get x ln x all squared minus, taking the 2 out, integral ln x dx. Now this part is another integration by parts, so we have to reapply the formula. Let u be equal to ln x, du is equal to 1 over x dx. dv is equal to dx, v is equal to x. U times v, that's x ln x, minus integral v, that's x, times du, 1 over x dx. We get x ln x minus, the x's cancel out, integral 1 dx, that's just x. So let's put that in the box and substitute it back in here. So the result will be x ln x squared minus 2 times x ln x minus x. Now that's the final result. Now let's evaluate it from 1 to e. Substitute the upper limit, we get e times ln e all squared minus 2 e ln e minus e minus, put the bottom limit in, we get 1 ln 1 all squared minus 2 times 1 ln 1 minus 1. Now ln of e, that's log to the base e of e, that's just 1. ln of 1, that's log to the base e of 1, that's 0. So this is 1, this is 1, ln of 1, that's 0, ln of 1, that's 0. We get e times 1 minus 2e plus 2e, and this is 0, and we get minus 1 times plus 2 plus 2. So when we make all the cancellations, the result will be e plus 2. Sorry, that's a mistake. It is e minus 2, because we have minus 2 times minus 1, that's plus 2 times negative 1 gives us e minus 2. Alright, let's do another example. Here we have integral 0 to 1 x tan minus 1x dx. So we'll let u be equal to, easy to differentiate, let u be equal to tan minus 1x. And x dx, this part will be dv. Let's write that down. u is equal to tan minus 1x du is equal to 1 over 1 plus x squared dx. dv is equal to x dx. v is x squared over 2. Alright, let's apply the formula. That's u times v, x squared over 2 times tan minus 1x minus integral v, that's x squared over 2, times du, that's 1 over 1 plus x squared dx. We get x squared over 2 tan minus 1x minus 1 half integral x squared divided by x squared plus 1. Now notice that degree of numerator is equal to degree of denominator. In this case we have to do long division. So x squared divided by x squared plus 1. X squared goes into x squared one time. 1 times x squared is x squared. 1 times 1 is 1. Subtract negative 1 remainder. So we can write integral x squared over x squared plus 1 dx as 1 plus negative 1 divided by x squared plus 1. So let's put that in. We get x squared over 2 tan minus 1x minus 1 half times 1 minus 1 over x squared plus 1. Integral, so we have an integral here, dx. Let's integrate this. We get x minus antiderivative of 1 over x squared plus 1, that's tan minus 1x. Here's the negative 1 half, put bracket here, x squared over 2 tan minus 1x. Alright, let's evaluate the limits. 0 to 1, that's going to be 1 half tan minus 1 of 1 minus 1 half times 1 minus tan minus 1 of 1 minus, put 0 in, you get 0 minus 1 half times 0 minus tan minus 1 of 0, which is just 0. Now from the special triangle, tan minus 1 of 1 is just pi over 4. That's pi over 4. So the result is 1 half pi over 4 minus 1 half plus pi over 8. So that's pi over 8 plus pi over 8, that's 2 pi over 8, that's pi over 4 minus 1 half. That's the answer. Alright, let's do another example. Here we have integral x cubed e to the x squared dx. The strategy is, first we use change of variables substitution method of the form t equals x to the k. Then we integrate by parts. Let t be the inside function, t is x squared, dt is equal to 2x dx. Algebraically solve for dx, dx is equal to dt over 2x. So integral x cubed e to the t, solve for dx, that's dt over 2x. Bring the 1 half out, x cubed over x is x squared, e to the t, dt. Now let's solve for x squared. X squared is equal to t, so we'll write that in. We get 1 half integral t e to the t dt. Now this is a pattern where we can apply integration by parts. Choose u easy to differentiate, choose dv easy to integrate. T is easy to differentiate, e to the t is easy to integrate. In fact, they're both easy to differentiate and integrate. So we'll let u to be the polynomial, let u be equal to t. Du is equal to dt, dv is equal to e to the t dt, v is equal to e to the t. U times v, that's t e to the t, minus integral v, that's e to the t, times du, that's dt. So we get t e to the t minus e to the t 1/2 times all this. That's equal to 1/2 times t, which is x squared, e to the x squared minus e to the x squared plus t. This is the answer. See you next time. I need to make a correction. On page 2, we had integral 0 to 1 x tan minus 1x dx. At this step, we need to write integral 1 plus negative 1 over x squared plus 1 dx. This is after we did a long division. Thanks.